All right, so I want to give an update on the clock and how I'm progressing by showing some of the things I've done besides working on the main part, sort of additional studies that needed to be done. So what we have here is a test vehicle I made when I first started because I was worried about the lifetime of relay. There are 86,000 seconds in a day, and I was concerned about that first relay just being, hit a lot. Data sheets I found for relays from reputable manufacturers, not these or these Amazon specials, says their lifetime is a million to 100 million operational cycles. So I was concerned, 86,000 operations in a day for the seconds counter. That means that in a week or 2 weeks you've surpassed the rated lifetime. And of course, that's under heaviest loads and so forth. But I wanted to do a test, so I made this board. And there's an Arduino here, and I have 3 relays, and they're wired up so that the Arduino cycles the relays repetitively. And so if I press this start button, the relays just keep on turning on and off. The Arduino has inputs that monitors if they actually have switched, and it keeps a track of the cycle count. So, and I can also stop it, and then I can restart it. And it keeps on banging on the relays, and if there's a failure, which I can simulate by removing this wire, that red LED comes on, and I get a failure, and I have the cycle count in which it failed at. And this is good because I want to run this several million cycles, which I did. I set it up over the weekend, put it in the laundry room, covered over with a blanket, and I ran it, and I think in all total I got 5 million cycles on it, and everything was fine. Not worried about the degradation. Mainly it's the contacts arcing if there's a high current across it, but there won't be in this case. So that's my relay tester board. Kind of fun. I can take it apart now since I've documented it. The other thing that I did is for my PPS source, I had shown this RTC clocks circuit in the previous video, and coming out is a 32 kilohertz. It's actually 32,768, which is 2 to the 15th, and that comes out, and there's a crystal on there. It's I think 50 ppm, and I have to divide it down to get my 1 pulse per second, and so I'm doing that with a ripple carry counter, and it's a 4040, and it's a 12-bit counter, and so that's why there's 2 of them. I have to divide it by 15, and so what this is, it's a binary counter, and so you send in the 32 kilohertz here, and at various points there are divided down versions of that. So the clock comes in at pin 10, and bit 12 is the divide by 2 to the 12th stage, and then that goes out, and that feeds into a second binary counter to divide it down further. And so you can see I'm on output 3 of the second stage, so I'm doing a total of divide by 2 to the 15th, which is 32,000, which gives me 1 pulse per second. And I can actually look at, with this LED, I can look at some of the other bits. This is the 2 to the 14th bit. It's going a little bit faster. This one's going twice as fast. This one is going even faster, and so on. But I know that this bit is 1 pulse per second. And actually, with my oscilloscope, I was able to measure the actual frequency as being from this guy as being 32,768.9. So it's off by a small amount, which is within the spec of that part. So that's good. So this will be initially, when it's in dumb mode, my source of an accurate 1 pulse per second. There'll also be, as I showed before, the GPS unit, which I can use to actually set the time in here so it will remember it when it boots up, and that will set the clock and have it go. And if there's no GPS signal, which I'd want to use that pulse per second, I can also default to using the pulse per second out of this, through all the dividers into the clock relay. So that's what I'm working on right now. I've done a lot of work on the hours function, which as soon as I get some more Nixie tubes and actually can adequately describe it, I'll do a video for that. So anyway, thanks for watching. Hope to have another video by the weekend when Nixie tubes come in. Thanks for watching. Bye.